Hello friends, welcome to Susan and John Matthew. In the last two videos, we were focusing on solving partial differential equations with separation of variable method. Now listen to this point very clearly. If you analyze the past paper questions, let it be from the new syllabus or the old syllabus, you'll see two questions being repeated. Number one, derive and hence solve either the wave equation or heat equation. And the second question will be an applied problem, a practical problem related to heat equation or wave equation. So I'm 99.99% sure that in the coming exam also they will ask almost the same pattern. Anyway, in this video, I'll give you a very important trick so that you can solve the applied problems related to wave and heat very easily. By the way, in the new syllabus, they can ask up to 10 to 12 marks from this wave and heat part. Basically, the modeling. Now, if they ask you to derive and solve the wave equation or heat equation, we will always go for the classic method, that is separation of variables, and that is why we learn that properly. Now comes the second part. If they ask you applied problems related to wave or heat, we will use the following method. And don't skip this video, and this is a very important video so that you can actually solve any problem related to wave equation or heat equation. Okay, now I hope you have some paper and pen so that you can write the very important points along with me. Now, point number one, you have to learn to identify heat equation and wave equation. Very easy. Heat equation will be in the form ut is equal to uxx. I'm giving the raw form. It can vary a little bit with constants or etc. Anyway, heat equation means it is a decay equation because after heat transfers from one body, the hot body, to the colder part, it will start decaying. So you have to expect an exponential function with the solution. And wave equation is all about vibration, and our common sense tells us it will be connected with sine and cosine. And the format of the wave equation is utt is equal to c square into uxx. You learn these things when you learn the derivation. Okay, so point number one, learn to recognize heat equation and wave equation. And don't forget, I'm talking about the applied problems related to heat and wave. Okay, now point number two. Note it down. This is extra important. A heat equation will have the end solution. Means let it be any heat equation. You can assume the solution to be ux comma t is equal to sigma an multiplied by sine n pi x by l e to the power minus n square pi square by l square into t. And for wave equation, the final solution will be, if you do not memorize this, then you have to apply separation of variable method, spend approximately 5 minutes till you get this step, and that will waste a lot of time. Now for wave equation, the end solution will be sigma an cos n pi c t by l plus bn sine n pi c t by l, the whole multiplied by sine n pi x by l. This comes from the derivation. Once more, let me repeat. If you are working with an applied question related to heat or wave, you can write this solution in the beginning. You can write like the given equation is a heat equation. So let the solution be. Okay, now look at this. Now, the trick in all the problems is how you apply the boundary condition. Now, please write case 1. Imagine in a problem it is given u x comma 0 is equal to some function. It can be given as a linear or a quadratic or any function. So what you have to do is you have to replace this part, let it be heat or let it be wave. You have to replace this part with the function and you have to plug in t is equal to 0. Now this is where we get our advantage. Come on, when t equal to 0, we get e to the power 0 which is equal to 1. So this whole part will become 1. And in the wave equation, cos 0, what is cos 0? Cos 0 will be 1. So this whole part will become 1. And since sine 0 is 0, this will vanish. And at the end, you're going to get f of x equal to sigma an multiplied by sine n pi x by L. Does it sound familiar? Have you seen this somewhere in some other chapter? If you have not seen that chapter, you're going to lose 18 marks in the new syllabus. Okay, this is our Fourier sine series. Anyway, you should not mug up this as Fourier sine series. But if you see sine here, you have to use the sine formula. If you see cosine here, you have to use the cosine formula. That's the best way to study for any applied problem. Anyway, an is given by 2 by L integral, whatever be the limits. Basically, it will be 0 to L because it's given L. But when I taught Fourier, you might remember, you put basically the limits given by the period. Function, this f of x multiplied by sine n pi x by L. I hope you remember this formula. I hope you're still writing the important points. So once more, let me make it very clear. If it is a heat equation, it looks like this. Wave equation looks like this. In heat equation, you can write the final answer to be like this. And wave equation, this model. And if the initial condition is given to be u x0 is a function, that means you plug in t equal to 0. And by default, you don't have to even waste time thinking. You can write like this, f of x equal to this in all problems. Okay, now in wave equation, only in wave equation, they might give you one more condition. That is the partial derivative with respect to t is equal to g of x. It might be given. You can check out the problems. You'll see this. In wave equation, the solution is uxt equal to sigma an cos n pi ct by L plus bn sine n pi ct by L. Some of you might be planning to take your exam tomorrow. So it is better to memorize the formula right now. Multiplied by sine n pi x by L. Anyway, I want to plug in t equal to 0, but the problem is this is not the function. So in such problems, you differentiate this solution with respect to t. And the derivative of cos is minus sine and the derivative of sine is cos. So eventually I will get n pi c by L. This comes common. And inside minus an. How did I get minus? Because the derivative of cos. Sine n pi ct by L plus bn. Here it becomes cos n pi ct by L. The whole multiplied. Because we are doing partial derivative. This part will be treated like a constant. N pi x by L. Now I'll plug in t equal to 0. Come on, tell me. I had to rewrite this as g of x. Like I told you, g of x can be any function. So g of x equal to sigma n pi c by L. And this will vanish. This will become 1. So eventually I'm going to get bn sine n pi x by L. Okay. Now, if you do not remember, I'm warning you, you're going to lose 18 marks. This part is Nothing related to wave equation or heat equation. It is connected with Fourier series. And can you see, I want a sine series. Can you see? If I want to find this Bn, I want a sine series because it is given sine. If I get cos, then you have to apply cosine series. That as simple as that. So I'm going to apply Fourier. So n pi c divided by L multiplied by Bn equal to, come on, tell me the formula. 2 by L integral 0 to L g of x multiplied by sine n pi x by L dx. Now this L gets cancelled. So we get Bn equal to, by the way, get connected with us. Bn equal to 2 by n pi c integral 0 to L, etc., etc. Okay, now there are many students who are very lazy to derive all this. They love shortcuts. So if you see this, I mean, those students who do not want to derive and waste their time, you can apply Bn equal to this much if you can store this in your brain. Anyway, personally, I don't like that. I love to derive this part. It just takes like 1 minute. Okay, now one more thing, one last thing, and that's it. Once more, do not skip this video. If you skip this video, then you will not be able to solve the problems comfortably. Okay, now the last thing. Sometimes they will give a very cute condition, that is ux0 equal to pi alpha into sine pi x by L. You'll see this problem in the next video. So can you see the boundary condition looks so cute? And instead of f of x, come on, here I told you it might be any function. Here also I told you it can be any function. But just imagine they have given a trigonometric function which looks like our solution. So all you have to do is you have to observe the number here. I'll give you another thing. In another problem, imagine the initial condition looks like 5 sine 3 pi x by L. So you have to look at the node. Can you see? In such cases, you just write a1 equal to pi alpha, this part. And here you can write a3 equal to, because that it's a third node, so a3 equal to 5. So I'll be back with more numericals related to this chapter. So till then, my friends, bye.